Hi Year 2s, it's Mrs Pearce here. I just wanted to do a bit of a recap with you on the work that we've done on 2D shape. And when we talked about 2D shapes, we learned that these types of shapes are special in the way that they're flat compared to other shapes that we've learnt about. They're shapes that can't be picked up, they're a drawing on the floor or on the wall, or they're the shape of something on the side of a 3D object. Okay, and then also we looked at lots and lots of words to describe these shapes. If you remember, we called those their properties. So what we're going to do today is we're just going to have a look and see if we can remember the names of all the shapes that we've learned, and also if we can name their properties that prove that they're the shape that we think. So a quick recap on the names of the shapes. Okay, so we've got a rhombus, we've got a triangle, an octagon, we've got a circle, rectangle, square, hexagon, pentagon, and a circle. I can't remember if I said that one already. So they're all of the shapes that we're going to have a little talk about this afternoon. I've also written down all of the words that we have used to describe all of these shapes. So we've already talked about the fact that these shapes are 2D shapes because they're flat, okay, and we've used the word flat just now. We also, one of the ways that we prove the name of the shape is by counting how many sides it's got. All of these different shapes have got sides. And then we described those sides by saying whether they were straight or whether they were curved. And curved is the same as round, but it was just a better word that we liked. And then I've also got corners. And then an even better mathematical word for corners that we used when we did our shapes was vertices. Vertices are corners. And we also looked at lines of symmetry. So we looked at when we folded those shapes in half, if you remember, they were symmetrical or had a line of symmetry if the two halves of the shape were the same on both sides, if they were a mirror image of each other. Equilateral, I wonder if anyone can remember what equilateral means. Well, equilateral means that the sides were all the same length on that particular shape. Another way of putting that means that it's a regular shape. Regular means that all of its sides are all the same at the same length. So if it's an irregular shape, then that means that they are not all the same length in sides. Because if you remember, if we have a pentagon, we could have a regular pentagon, like this one, where all of the sides are the same length, but any shape, any 2D shape that has 5 sides and 5 corners, or vertices I should say, is a pentagon. It's just that it's an irregular pentagon. Okay, and then I've also got right angles, which we talked about as well, and we found there were some of these shapes that had right angles where those sides, where it went straight across and straight down, where it met in the corner, that was a 90-degree angle, and that's called a right angle. And not all shapes have those. I wonder if you can have a look and decide what of these shapes does have a right angle. Okay, right, so thinking about all that language that we've just recapped, I'm going to play a little game with you, and I'm going to describe a shape. So I've thought one of these shapes I've chosen and it's in my head, okay? I'm going to use lots of really good mathematical language to help you guess what my shape is, okay? Are you listening? My shape is a 2D flat shape, which you know because they're all here. I've got pictures of them all here on the wall. My shape has got 4 vertices. Remember what are vertices? That's right, they're corners. So we've got a shape that's got 4 corners. So what shape could my shape not be? because remember, Mrs. Pearce really likes it when we're mathematicians and we're trying to prove things all the time. So who could tell me a shape that it definitely could not be if my shape has got 4 vertices? Well, it definitely can't be a circle, can it? It can't be a circle because a circle doesn't have any vertices at all. It can't be a triangle because a triangle has 1, 2, 3 vertices, and my shape has definitely got 4 vertices. My shape can't be an octagon because an octagon has got 1, 2, 3, 4, 5, 6, 7, 8 vertices, and my shape's only got 4, so my shape's got a lot less vertices than an octagon. My shape can't be a hexagon because a hexagon has got 1, 2, 3, 4, 5, 6 vertices, and my shape's only got 4. Okay, so what shapes could it be? Let's see what's left then. My shape could be a square because a square has 1, 2, 3, 4 vertices. My shape could be a rectangle because that also has 1, 2, 3, 4 vertices. Or my shape could be a rhombus, which has got 1, 2, 3, 4 vertices as well. So it's one of those 3, isn't it? So keep having a think, children. I'm going to give you my next clue. My 2D shape has 4 sides. And these sides are straight. My shape is also equilateral, which means that all of the sides are the same length. So what could my shape not be first? Let's be a little bit tricky. What shape could it definitely not be? It's got 4 straight sides and it's an equilateral shape, meaning all of the sides are the same length. Let's have a look. Well, we know that it can't be the octagon because the octagon has 1, 2, 3, 4, 5, 6, 7, 8 sides, so it's definitely not the octagon, although it has got straight sides like my shape, and it is also an equilateral shape or a regular shape because all of its sides are the same length. The rhombus, I'll come back to that one in a minute because we know that's got 4 sides, so it could possibly be that shape. Will it be the circle? No, because the circle's only got 1 side, and what's very special about the circle compared to all of the other shapes, I wonder if you can spot it, it's round. It's a curved side on a circle, which is different to all of the other shapes. Right, so what else could it not be? Well, it definitely can't be a hexagon. The hexagon has got straight sides, and it's also an equilateral because all of its sides are the same length, meaning it's a regular hexagon, but it's got 6 of them. 1, 2, 3, 4, 5, 6, and my shape's only got 4. So could my shape be a rectangle? Well, let's have a look. It's got 1, 2, 3, 4 sides. Are they all the same length? They're not, are they? What's special about a rectangle is it has 2 long sides and it has 2 short sides. So my shape can't be a rectangle because mine has sides that are all exactly the same length. It's an equilateral shape, which means then that my shape can only be a square or a rhombus. So how am I going to describe this to you next? I think I'm going to say my shape does have 4 right angles. What shape could it be? Is it going to be the square or is it going to be the rhombus? It's the square. Well done. The square has got 1 right angle, 2 right angles, 3 right angles, 4 right angles, where the sides meet in an L shape, which makes 90 degrees, and that is called a right angle. Whereas you can see on here, they're either much bigger angles where you have to really stretch your fingers out, or they're smaller. And so the shape that my shape must be is the square, because it does have 4 right angles. I wonder if we should try another one. Let's have a go at another one. Okay, right, I have got a shape in my head, and you can now have a guess at what it is. I'm going to describe it to you again, trying to use as much of that language that I used before. Okay, my shape is a regular shape. So have a think about what regular means. Regular means that it has all sides that are the same length. Well, maybe the only one we could think about that isn't is the rectangle. So my shape can't be the rectangle, because the rectangle has got 2 long sides and 2 short sides, hasn't it? So it can't be that one. So I wonder what it is. Maybe it could be any of the others. My shape has got 5 vertices. 5 vertices. Remember, vertices means corners. So if my shape has got 5 vertices, what is my shape, do you think? Or what shape could it not be? Let's go for that first. Well, it can't be the triangle, because the triangle's got 1, 2, 3 vertices. It can't be the octagon, because the octagon has 8 vertices. It can't be the rhombus, because the rhombus has got 1, 2, 3, 4 vertices. It can't be the circle, because it has 0 vertices. Can it be the hexagon? 1, 2, 3, 4, 5, 6 vertices. No, so it's not that one. So what could it be? My shape has also got, can I tell you, it's got at least 5 lines of symmetry. So if I draw a line down it, I can see a mirror image in at least 5 different ways. My shape is a pentagon. You're quite right. So here we have a line of symmetry where it's the same on both sides. And then from each vertices, if we went straight down the middle, that would be another line of symmetry. And we could start at this one and go down. We've got another line of symmetry. And, oh, I've lost where I am now, but there's 1, 2, 3, 4, 5 lines of symmetry. So I'm going to give you a challenge, children. I wonder if you could design Mrs. Pearce a poster. And on your poster, I would like you to give the people looking at your poster some information about these shapes. So first of all, they need to know what these shapes are. So you need to draw them, and you need to make sure you label them with the correct name. And then if you fancy a bit more of a challenge, which I'm sure lots and lots of you do, I would like you to write down all the properties that prove that that shape is that name. So what properties has a triangle got to prove that it's a triangle? So you could tell me how many vertices, you could tell me how many sides and what those sides are like. Are those sides straight or are they curved? And you could also tell me about whether it has right angles, and you could tell me about how many lines of symmetry that shape has. And I'd like you to do that for each of those shapes and try and make it nice and bright and colourful for me, because I like bright colours. Anybody who can design that poster and send that in to Mrs. Pearce, I'm going to give a Wow Dojo to. Okay, so I'm really looking forward to seeing some of that. I'm also going to put some bits onto the website as follow-up work that you can do, particularly if you'd like an extra challenge. Have a little look out for that, because what I would like you to do is, out of 3 2D shapes, I would like you to look at them and see if you can tell me what's the same and what's different about them. Okay, take care everybody, bye bye.